Hello everyone, this is Sister Lindsay Celestine, Assistant Professor, Department of Mathematics, St. Josephs College of Arts and Science for Women. In this video, we are going to see Neyman Pearson lemma. Let us see the theorem. Let K be the constant and that is positive constant and W be the critical region of size L. Critical region means the region of rejection that we already know. That is that if the graph is like this, then some part, the set of values, all the rejected values are in this. In null hypothesis, all the rejected values are in one part. That is called region of rejection, critical region. That is we denoted as W. This critical region size is alpha. Okay, now we are defining this area as W equal to set of all x belongs to S such that f of x comma theta 1 divided by f of x comma theta the greater than k, which implies W is equal to, that means critical region is the set of all x values. Those x values are in S such that how the x values will be, the likelihood function under h1 divided by likelihood function under h0, it should be greater than the constant k. And the alternative part, the alternative part is w bar is the, we are defining complement of this equation. This L1 by L0 is greater than K, then we can say that is a double, that is W, that is those values are in critical region. If this L1 by L0 which is less than K, then we can say that those values are in the set W bar. So if it is like this, then we can say this W is the most powerful critical region of the hypothesis H0 against the alternative. We will say like that. Then you will see, before going to see the proof, first we'll see what is the most powerful critical region. The critical region W is the most powerful critical region of size alpha for testing H0 against H1 if the probability of x belongs to W such that H0. That means the probability of rejection. The probability of rejection, how can we define as integral over this W L0 dx. L0 dx means this likelihood function under H0. If we integrate that whole value, we will get alpha. And probability of x belongs to W under H1. Under alternative hypothesis, if we take the values of x and we take the probability, then it should be greater than the another one critical region W1. That is also under H1. That means P of x belongs to W under H0 is rejection, probability of rejection, and P of x belongs to W under H1 is probability of acceptance. Probability of rejection should be equal to alpha. And probability of acceptance of most powerful critical region should be greater than or equal to probability of acceptance of another critical region. If these both are there, then we can say this W as the most powerful critical region. Now we'll see the proof. We are given, they have given us that W is the critical region, most powerful critical region. So we are writing this equation. And the complement of that hypothesis, that means alternative hypothesis. For alternative hypothesis also, we are writing probability of x belongs to W under H1 equal to integral over W L1 dx H1. So L1 dx equal to alpha equal plus beta is equal to 1. So from this alpha equal to 1 minus beta. So this 1 minus beta we are writing here. In order to establish lemma, if we want to establish a lemma, we have to prove that there exists no other critical region of size less than or equal to alpha. Then which is more powerful than W? More than W, there should be no any powerful region should not be there. Okay, now let me consider W1, that is another critical region. Okay, that size is less than or equal to this size and power 1 minus beta 1. So that we have this also we told no, this is less than or equal to this one. So what I am telling means now I am giving the definition for alpha 1 and 1 minus beta 1. So like that same wise we are writing here. Okay, so probability of x belongs to W1 under H naught, that means probability of rejection in W1 under H naught is equal to alpha 1 and probability of acceptance under H1 equal to 1 minus beta 1. Okay, we know alpha 1 is less than or equal to alpha. Now we have to prove 1 minus beta less than greater than or equal to 1 minus beta 1. Okay, that one we have to prove. Okay, now we'll see before going to prove 1 minus beta is greater than or equal to this one. Now for that I am taking a Venn diagram. Let W equal to A union C and W1 equal to B union C. See, this is A and this is B. The intersection part is C. So these two combinedly will say W and these two combinedly will say W1. If this C may be empty, if it is empty, then we can say this and this are disjoint. Okay, now we have alpha 1 less than or equal to alpha. So in the previous slide itself, we have seen, in the previous slide itself, we have seen that alpha is equal to this value. Okay, alpha is equal to this value and alpha 1 equal to this value. This both value we are going to substitute in this slide. Okay, both value we are going to substitute in this slide. Then what will get W instead of alpha 1 integral over W1 k L naught dx less than or equal to integral over W L naught dx. Okay, W1 is equal to according to the Venn diagram it is B union C and W is equal to according to the Venn diagram it is A union C. That one we are substituting. So since this is union, I can write it as an addition. So B integral B plus integral over C is less than or equal to integral over A plus integral over C. So this integral and this integral will be cancelled. Then we have this one. Integral over B L naught dx less than or equal to integral over A L naught dx. So this one I am writing conversely. Okay. Now we'll see. Now we'll see the next one. Okay, since A is belong to W. Okay, now we know that. Now we have told that integral A L naught dx greater than or equal to integral B L naught dx. Now we have to see for integral A L1 dx and integral B L1 dx both we have to prove. Okay, now we'll see integral A L1 dx. Since A belongs to W, A is belongs to W, we'll say that L1 dx also we'll see. Okay, so belongs to W, then we can use equation 1. Okay, what is equation 1? This is equation 1. So W is equal to integral over x belongs to S, L1 by L naught greater than K. Now we have to see what L1. Okay, L1, isn't it? So from this L1, we are writing instead of L1, L1 is greater than K into this L naught will come to this side as multiplication. So L naught. Okay, this one also we can write when we come to W1. This one also I can write L1 which is less than K into L naught. Okay, for this is for W integral over W1 and this is for integral over W. Okay, this one we are going to apply in that place. Okay, if I apply there, so instead of L1, I am writing which is greater than K into L naught. Okay. So using the before equation, okay, k equal L naught dx is greater than or equal to, sorry, integral over a L naught dx is greater than or equal to integral over b L naught dx. That one we are substituting here. So greater than this part is greater than or equal to this part. Okay, this will take now from equation 2 is this one. Okay, L1 L1 by L naught less than or equal to k. Okay, using that we are writing. So if we write in integral over w bar L1 dx less than or equal to k, this one will go to this side. Okay, k into integral over w bar L naught dx. This result also holds for any subset of w. Okay, this is for all the subsets of w. So if I take intersection for w and w bar, okay, then we can get b. Okay, according to the Venn diagram, we'll see. Okay, according to the Venn diagram, we'll see. Okay, if I take this is w, isn't it? This is w. Okay, this part alone w. Then remaining all the part is w bar. Okay, this is all the part is w bar. So this is also w bar. Okay, so if it is in this, if we take this one as w, then this remaining part will be w bar. So that is b. If I take intersection for these two, okay, in w and w bar, then we will take, we will have the intersection part is b. Okay, intersection part is b. That only we have denoted here. We have denoted here. Okay, so hence integral over b L1 dx. Okay, integral of b L naught dx here it is there. We have to going to see integral b L1 dx. Okay, L1 means we told L1 means less than or equal to k into L naught. So which is less than or equal to k into L naught is less than or equal to L1. K into L naught is less than or equal to L1. So we are writing L1. So if I add both sides C, then here B union C and here A union C. According to the Venn diagram, we'll see. Okay, according to the Venn diagram, okay, B union C is W1, A union C is W. That one we are substituting here. B union C will be W1, A union C will be W. Okay, for this value, we have 1 minus beta 1, 1 minus beta. Okay, integral over W1, 1 minus beta 1, integral over W, 1 minus beta. Okay. So that's when we do 1 minus beta is greater than or equal to 1 minus beta 1, hence the lemma. That's all. Thank you.